Hi everyone, in this video we'll be talking about polyhedra. In particular we'll talk about regular polyhedra. So polyhedra are an extension of polygons. When we were working with polygons we were working in two-dimensional space. Here we're working in three-dimensional space, so we have 3D objects now. The first polyhedra that we'll look at, and there are only 5 regular polyhedra, so the regular polyhedra, if every face is the same regular polygon. The first one we're looking at here is a tetrahedron. Tetrahedron has 4 faces, it has 6 edges, and 4 vertices. So the vertices are the points. You can see them there. Okay, each face of a tetrahedron is a regular triangle. Next, we're going to look at a hexahedron. A hexahedron actually has a very nice name that's a little bit simpler. It's just a cube. So each side of our cube is a square. We have 6 faces, hence hexa. So we always get this sort of prefix from the number of faces rather than anything else in our polyhedra. So we have 6 faces, we have 12 edges, and we have 8 vertices. Next, we're looking at an octahedron, and you can guess from octa, it means that we have 8 faces. We also have 12 edges, and we have 6 vertices. Okay. Going up a little bit, here we have a dodecahedron. Okay, dodeca means, there we go. Dodeca means that we have, we're working with faces first, sorry. We have 12 faces. We have 30 edges and 20 vertices. Next, and finally, the 5th of our 5 regular polyhedra, this is an icosahedron. Icosa, that's for 20, so we have 20 faces. We have 30 edges and 12 vertices. So that's our icosahedron, so that's all of our regular polyhedra. A really cool thing that we know about polyhedra is Euler's formula. So Euler's formula tells us that the number of vertices plus the number of faces take away the number of edges always equals 2. And that's not just for regular polyhedra, that's for any polyhedra. And that's part of the reason why we can only have certain regular polyhedra. As I mentioned in class, the reason that we've got, because we've only got these 5 regular polyhedra, that's why in games like D&D, you only have certain die that you can use. So you might have a 4-sided die, a 6-sided, 8-sided, 12, or 20. Okay, and they're regular polyhedra, which means that they would be fair dies because you've got equal probability of landing on any of those faces. You can actually get higher dies in these sorts of games. You might get a D100, which is 100 sides, but it's not a fair die because you don't have the same probability of landing on each of these sides. So that also means that it's not a regular polyhedra because we've got different faces for those sides. Hope that helps.